Hi folks, this is Diffie Q Take Home 1. We're asked to solve this rather challenging looking differential equation. And to help us see the forest for the trees, we're going to want to do a substitution. Now, most of you made the substitution, you let u equal e to the minus xy, and then you eventually let w be u to the minus first, because this substitution turned it into a Bernoulli, and then you did the Bernoulli substitution. So what I'm going to do is I'm going to combine these two together and make one substitution. I'm going to let u be essentially what w was. W is u to the minus 1, so this to the minus 1 would be e to the positive xy. So I'm just going to show that. You can do one substitution and it counts for two. So that's what I'm going to do. I'm going to let u be e to the positive xy. And now what I need to do is figure out what's du dx in terms of dy dx and the things I already have. So if I look at du dx, it's going to be e to the xy times the derivative with respect to x of xy. So it's e to the xy times y plus x times dy dx. So if I rewrite this using primes, I have u prime is equal to e to the xy times y plus x y prime. And as I look at my differential equation, I see on the left-hand side the y plus xy prime. And so to get e to the xy there, I can multiply both sides by e to the xy. But I need to multiply e to the xy times that side. And so when I do that, I'll be left with x squared minus e to the xy cotangent x. And so I look at this differential equation, and now this left-hand side is my u prime. I get x squared. E to the xy is u cotangent x. And sure enough, if I rewrite this, I get a linear equation in terms of u. So I'm going to get my integrating factor, u, is e to the integral cotangent x dx. And the integral of cotangent x is the natural log of the absolute value of the sine of x. And then I go back. X is living between 0 and pi, so I don't really need those absolute values. It's e to the natural log of sine x. And e and natural log are inverse functions, so this reduces just to the sine of x. So multiplying through by the integrating factor, the left-hand side I get the exact differential, u times sine of x. On the right-hand side I get x squared sine of x dx. Alright, so that means that u sine of x is the integral x squared sine of x dx. This is an integration by parts that we can handle with the tabular method. So Zoki lives. I'm going to have the u column. Well, I guess u is a bad choice. I'll call it the w column and the dv column. So I'm going to take derivatives here. I'm going to take antiderivatives here. So we start off, I have x squared, 2x, 2, and 0. I start off here with sine of x, the antiderivative of sine, negative cosine, antiderivative of cosine, negative sine, antiderivative of negative sine is cosine. And then I go diagonally, multiplying by a plus 1, minus 1, plus 1. And so I have u sine x equals minus x squared cosine x plus 2x sine x plus 2 cosine x plus c. So I can solve for u then by dividing through by the sine x. Once again, x is between 0 and pi, so sine isn't 0. This is fine. Minus x squared cotangent x plus 2x plus 2 cotangent x plus c cosecant x. And last but not least, I remember what my substitution was. U was e to the xy, so I have e to the xy equals this. And once again, since x is greater than 0, I can go ahead and take the natural log of both sides if I wanted to. This is as far as you needed to go. This is your implicit solution. To get an explicit solution, we can take the log of both sides and then divide by x. And so if you wanted an explicit solution, you'd have that, okay, on the natural log. Only one of you thought to do that, so that was worth an extra hidden bonus point. And that'll do it for Take Home 1.